Hey, welcome back to the tutorial. In this video, let me start with some of the debugging features of the Atmel Studio 7. So in this lecture, I'll be using the Atmel Studio and the Arduino board. All right. So to be specific, it is Arduino Duo board. And as you know, the Arduino doesn't come with onboard debugger, isn't it? So that's why I'm using a external debugger. Okay, this is actually Atmel ICE debugger. All right, so I'm going to talk about the different kinds of debugger later in this course. So for a time being, just think that there is IDE, that is our Atmel Studio 7. And there is an external debugger, okay, that is Atmel ICE, and that is a Arduino board. All right, so in this lecture I'm going to show you the stepping in, stepping out, stepping over, adding variable to the watch window, and also I'll show you the IO view of the microcontroller, okay, and how you can control your LED through that IO view. All right, so here I have a small piece of code. The code doesn't do much, okay. It actually makes the GPIO high and then it makes it low. All right, so I'm just using two APIs provided by the Atmel Studio, and that's it. Okay, so this piece of code I have taken to explain the debugging features. So first, what we'll do is, first we will put the board into the debugging mode. Here you can see my Atmel IC is already connected to the PC over JTAG, and this software has detected that the microcontroller is of SAM3X80. All right, so this application doesn't do much, okay. This is similar to what you saw before. It just makes GPIO pin high and then low, that's it, okay. And this is sufficient to demonstrate some of the debugging features. All right, so now let's keep the board into debugging mode. For that, click on debug and then click on start debugging. All right, so here you can see the cursor begins from main, okay. So when you put the board into a debugging mode, always it starts from main. All right, so after that, okay, if you want to execute line by line, okay, so then you can click on this step over. All right, so when I click step over, okay, it executes line by line, okay. So it doesn't go into the function. Here you can see it is currently, the processor is currently halted at this line, isn't it? So when I click step over here, this function will run in the background and the cursor will come to the next line, okay. So let me click once again. Here you can see this function ran in the background, and now the cursor is pointing to the next function. So if you want to go into this function, you have to click step into, okay. So when you click step into, it will take you into the function, and here you can again execute the step over to execute each line. All right, like this, okay. So now you are in the middle of this function, isn't it? You are somewhere here, okay. So now if you want to come out from this function, then what you have to do is, okay, you have to click step out. All right, so once you click step out, so this control will immediately comes out of this function. That means it will execute all the remaining lines in the background and it will immediately comes out of this function. So let's click step out. Here you can see we have stepped out from this function, and now we are in the main, and the cursor is pointing to the next line of the main function, okay. So if you click step into, it will go inside to the function. All right, and here if you click step out, then it will comes out of this function and it will start pointing to the next line. All right, great. So that's about stepping in, stepping over, and stepping out. All right, Great. So now let me tell you how you can set a breakpoint. So now let's restart everything. For that, go to debug and click on restart. Alright, so when you click restart, so your board will be reset and everything will start from once again. So now the cursor is again pointing to the main. Alright, so now setting the breakpoint is very easy. Okay, so if you want your processor to halt at a certain instruction, then you can do that by using an instruction breakpoint. Alright, so for example, so you are seeing this gray area, isn't it? So here, so if I click here, so it will insert an instruction data point. Alright, so when the processor comes to this instruction, the processor execution will halt at that point, okay, where you have inserted the breakpoint. Alright, so another way of inserting a breakpoint is simple. So just select this line, right click and click on breakpoint. Okay, so insert breakpoint. So the easiest way is just click on this gray area. Okay, so in front of this line, that's it. So now when you hit run, that is this play button, all right, the processor will execute all these instructions. All right, so but it will halt, okay, at the instruction where you have inserted the breakpoint. So if you want to know what exactly this instruction, just click this and select go to disassembly. All right, so here you can see the processor has stopped at this instruction. So this is the assembly code generated for this function call. Okay, so and in this assembly code, this is the very first instruction, isn't it? So that's why the processor stopped at that point. All right, so again click this red circle over here, which will remove the breakpoint, and you can again click somewhere here. It will again insert the breakpoint, and then you can click this play button again, and you can see here the processor again halted at this instruction. All right, so again if you click here and right click and select go to source, it will take you to the source code of that instruction. All right, so we are still in the GPIO configure fin function. Okay, that's because this whole code segment is related to this function. All right, great. So now at this point, if you want to see the register windows, then go to debug and click on Windows, then select the processor status. All right, processor status will show you all the processor specific registers. So in this case, the processor is ARM Cortex M3, isn't it? So that's why it will show all the processor details related to ARM Cortex M3. Here you can see these are the register details from R0 to R12. All right, and this is your program counter, this is your stack pointer, this is your LR register, this is the MSP, this is the PSP, and these are the status registers, that is, this is the APSR, IPSR, XPSR, and this is the priority mask registers, base pre-register, the control register, and all the status registers. So in the next lecture, I will talk about how you can add variables to the watch window, and also I will talk about the IO view of the Atmel Studio 7. Alright, so see you in the next lecture.